So before you can understand the concept of integration, please do well to go watch our video on differentiation. Now, differentiation tells us how fast something is changing. That's the rate of change of something with respect to another thing, right? Okay, so that's why we have the dy dx. Okay, all right. Now, if differentiation tells us how fast something is changing, then integration helps us walk backwards and find the original function. So today I'm going to make integration so simple that you will wonder why it even looked difficult at first. All right. Now, if I tell you that the derivative of x cubed, if I tell you that the derivative of x cubed is equal to 3x squared, what would you do if I gave you 3x squared and then ask you to find the original function? I repeat the question. If I tell you that the derivative, that's the first derivative of x cubed with respect to x is 3x squared. What happens if I give you 3x squared as that first derivative and then tell you to find the original function? What will happen? That original function is x cubed, right? What happens? So that leads us to today's topic, integration. So what is integration? Integration, simply put, is the reverse of differentiation. So now the question is, why is it important that we learn how to integrate, or why are we learning integration? So now if integration is taking us forward, if differentiation is taking us forward and integration is taking us backwards, it means that integration can be used to find area under curve. There are certain areas you cannot find with just geometry. Integration helps us to find such areas. Velocity from, if you want to find displacement, let's say for physics students, this class is also for you. Now, let's say you've been given velocity, right? Okay, and then you need to find displacement. You know, from velocity, if you move forward, what you will find will be acceleration, right? And that moving forward is differentiation. Remember, differentiation is taking you forward, right? Then if you now want to move back, let's say you have been given velocity, for instance, and you want to find displacement, which is going back, what do you do? Because of course you cannot differentiate. Differentiating means taking velocity forward, and that forward is acceleration. So what happens if I have velocity and I need to find displacement? You see, that's why I need to learn integration, that is moving back. Or I have acceleration and I need to find velocity, I am going back. And that is one of the things we use integration for. Then if you want to find original function given its derivative, just like I told you that a function f of x is x cubed. So if I differentiate it, I have 3x squared. That's the first derivative, right? Now, what if I give you that first derivative and I tell you to find the original function? What happens? You see? So these are the things we use integration for. So now, having known why we are learning this, now tighten your seat belts. Let's roll. Now, in integration, we use a symbol. This symbol is called the elongated s, x cubed. This is what we mean with respect to x. So this is how we write integration. The integral of 4x cubed with respect to x. So now, generally, how do we integrate? Generally, if I have the integral of x raised to the power of n with respect to x, this is equal to x raised to the power of n plus 1. I will add 1 to the power. When I add 1 to the power, I will now divide by the new power, which is n plus 1. And then I add my constant c, the arbitrary constant c. So this is the general formula for integration. So now, My question is this: what is the use of this arbitrary constant? What is it doing there? So if I give you a function, let me explain, let me answer that question. If I give you a function f of x or y to be equal to, let's say 2x squared plus 4. This is my function. Now, if you differentiate this, differentiating this function will give us, in differentiation, integration and differentiation are like words and opposites in English language. In differentiation, we remove from the from the power rather. But before we remove, we multiply the coefficient of x by the power, right? That's 2 times 2, 4. And when we multiply first, we now remove 1 from the power. While integration is saying before you do anything, add 1. That one we have removed. Why differentiating? First of all, add it first. After adding, divide. While integration, because that's the only way you will get back your function. All right, good. So now if you look at 4 is a constant, it doesn't have x. So if you integrate a constant, you have 0. Okay, so now the first derivative here is going to be equal to 4x, as simple as ABC. Now it is 4x. So what if I give you I tell you that the y dx is equal to 4x, you should find the original function. If you integrate it that way using the formula given to you, the integral of 4x with respect to x, if you do it literally, you're going to have 4x, the power of x here is 1 already, so you add another 1. So the new power becomes 2. You divide by that 2, right? And when you do that, 2 divide 4 will give us 2. So we have 2x squared, right? But the function given to us originally is 2x squared plus 4. So you see, we're having 2x squared. So what happens to the 4? That is the work of the arbitrary constant c or k. You can use c, you can use k. Please don't use any other letter aside this c and k to avoid a mix-up. All right? Okay. So now this c there is there to take care of that constant because we don't know it. The reason why you know that it is 4 is because I gave you the function originally. All right? So what if the function is not given? What if it's the derivative that is given and you are told to find the function? How will you know the constant that is in the original question? So we use the arbitrary c to take care of that constant. Okay, so now we have two kinds of integrand. We have the definite integrand and then we have the indefinite integrand. And we are using c to represent it. So it is regarded as an indefinite integrand because the constant is not known. The reason why in this case it's known is because you've seen the 4. So if I give you another question, you don't know what that C is till tomorrow. Even if there are 10 questions, you're just writing C, C, C. You don't know it. You don't know what C is. So it's indefinite, right? Now, but for definite integrands, you have a clue on how you will find your C. So when you find your C, you replace your C with the value you've obtained. So what helps you find your C? One, either the limits are given, x limits, the upper and the lower limits are given 1, or the x and y values are given. So in such case, when you integrate, at the end of your integration, you substitute, you minus the lower limit from the upper limit to find your c, and then go back to your integrand and replace your c with your value. Or if it is in the case of x and y values being given, when you are done integrating, you substitute the values of x and y and then find your c. So when you find your c, you replace your c. That means, oh, I have known my value for, or my integral value, as the case may be. Do we understand? Okay, so that is basically the difference between definite integrands and indefinite integrands. So when we will use these definite integrals very well is during the application when we're looking for area under curve, because in that case you must know your limit. Yes, we're talking about area in this time around. So that's when we usually use these definite integrals very, very well. Okay, so now let's look at a few questions together. of 3 with respect to x. So if we integrate x raised to the power of 5, that will be x raised to the power of 5, add your 1, that's our golden rule. When you add your 1, you have a new power, which is 6. Divide by that new power. Plus, okay, now for us to have just 3, it means that this 3 is multiplying x raised to the power of 0, right? Okay, so now what do? What we'll do is that we will add 1 to this power of 0. So when we add 1 to this power of 0, we have a new power, 0 plus 1, which is 1. So we divide by it. Then do not forget to add your constant c or k. Don't. So we'll have x raised to the power of 6 over 6. So 0 plus 0, 0 plus 1 will give us 1. So we have 3x, so whether we put the 1 or not, divided by 1. For this second question, we have a power that is bigger than 2. So if I, assuming the power was 2, we would have chosen expansion, that's if we wish to, right? Now, but we need to learn how to integrate by substitution. Okay, so because if you have raised to the power of 2 and you choose to expand, what happens when the power is a fraction or a negative index? So what happens? So we need to learn how to integrate by substitution. So we say let u be equal to 3x plus 5. So if we equate u to be equal to 3x plus 5, now look at the implication of that. The implication is that we're going to be having the integral of u cube with respect to x. So you cannot be integrating a variable with respect to another variable. All right? So what happens? So what happens is that we're going to be differentiating this u. Since we are saying let u be equal to 3x plus 5, so we differentiate u with respect to x. Because if we're going to be replacing 3x plus 5 with u, that means that the x has to be changed to the u. Right? So differentiating u with respect to x will be equal to 3, right? So we make the x subject. So when we cross multiply here, we have the u to be equal to 3 dx, right? So when we divide both sides by 3, our dx becomes equal to du over 3. So now we can proceed. Okay, we can proceed. So we have the integral of u raised to the power of 3 with respect to the u over 3. Now I have a constant and I don't want something to be, disturbing my eyes. So I want to push the constant to the back of the integrand, right? Okay, so I will have 1 over 3 integral u cube du, so that I will see clearly and know what I'm doing. Okay, so now integrating, you know that 1 over 3 is a constant, so you will not even integrate it. So there's no need. Okay, so if you have x over 3, just know that that 1 over 3 is a constant. If you have 3x, just know that that 3 is a constant. You are not integrating it. So if you can decide to, if it will not block your eye, you can leave it there. If it will block your eye, just like this one is blocking my eye, push it to the back of the integrand. The only constant you integrate is when the constant is standing on its own. For instance, you have x plus 3. The 3 is standing on its own. It means that that 3 standing on its own is 3x raised to the power of 0, just like the first example we solved. Okay? So now if we integrate u, integrating u cube, we will have u raised to the power of 4, that's 3 plus 1, then divide by the new power. And then you add your constants plus c, right? Okay. So you can choose to leave it like that or further have it as u raised to the power of 4 all over 12 plus c. Now remember that u wasn't in the original question, we actually substituted. So recall that u is equal to what? X raised to the power of, okay, 3x plus 5 So replacing, we will have 3x plus 5 over 12 plus c, and that is that. So we can't simplify further. Assuming that 5 there was a multiple of 3, we would have factored out and then reduced the fraction further. So moving to the next question, number 3. The question number 3 says, in the integral of sine squared x with respect to x. Very, very important question. Now, to integrate this, recall the what? Recall the half angle identity. Now, that half angle identity says that, if this were to be the integral of sine x, if you integrate the integral of sine x, very simple, you will have what? Minus cos x. Very simple. But this time around, we have sine squared x. So now, to integrate sine squared x, whether it is sine squared x or cos squared x, what do we use? We use the what? Half angle identity, which you have done before. So now, when you have sine squared x, it will be equal to 1 minus cos 2x all over 2, right? Good. So now, if sine squared x is 1 over 1 minus cos 2x over 2, it will mean that the integral of our sine squared x with respect to x will be equal to the integral of 1 minus cos 2x over 2 with respect to x. Okay, now for this to be very easy for us, there's something I used to say, like when we're solving number 2. I like taking the constant to the back of the integral, since it's not useful, so that it doesn't make our question look complex. So taking half to the back, we have 1 minus cos 2x dx. You see, it's looking better now. So if you also choose 2, you can further use sum. So breaking down further, you can have half the integral of 1 dx minus the integral of cos 2x dx, right? So doing it 1 like that, we will have half. If I integrate 1, what will I have? I'll have x. That's x over 1, right? Which is still x. Okay, minus, if I integrate cos 2x, let me show you something here. If I have cos ax, cos ax will be equal to sine ax over a. So just know it any day, anytime, that if you are to integrate cos ax, it will give you sine ax over a. So don't bother yourself bringing in chain rule, trying to, do all this. Okay, try to use substitution again. Let 2x be equal to u, then cos u, running round and round. Just know that cos ax is equal to what? Sine ax over a. Okay, so that will give us sine 2x. In this case, our a is 2 over 2. So what am I omitting, or what am I forgetting? Nothing. Let me put my constant. Boom. Okay, so if I open the bracket, multiplying through by half, I will have x over 2 minus sine 2x over 4 plus c, as simple as ABC. So I want you to, you see this this question we just solved. I want you to try it on your own. Then when you try it on your own, try to integrate cos squared x, and then let's know what you have. Okay, now moving further to the fourth question as we gradually come to the end of today's class. Moving further to the fourth question, we have the integral of 3x over x squared minus 1. Okay, let me use this question to explain something. Whenever you have integration that has to do with fraction, let me tell you the first thing that should come to your mind. Number one, check if you can factorize either the numerator or the denominator, and then something will be able to cancel out and you have a reduced expression to simply integrate. If that doesn't work, just like in our case, there's nothing that will cancel out. Even if you decide to split the fractions, there's nothing will happen. It will still be there. All right, nothing changes. Now, if you try this one thing I've said and it doesn't work, the second thing to check is if the numerator is the first derivative of the denominator. I repeat, you check if the numerator is the first derivative of the denominator. Now, assuming this question was 2x over x squared minus 1. Now, this denominator is f of x is equal to x squared minus 1, right? If you differentiate it, you will have 2x, which is exactly the numerator. So in that case, we have ln what? The denominator, ln x squared minus 1 plus our c. As simple as ABC. Do you get it? So I've given you the first thing to try when you have a fraction to integrate. If it doesn't work, check for the second. If you check the second and it still doesn't work, just like the question we have, our own is 3x over x squared minus 1. So none of these two things I've mentioned is going to work. So what do? We can now talk about integration by partial fraction. Okay, so now using partial fraction, we have 3x over x squared minus 1. So if you look at the denominator, you see that we'll have difference of two squares, right? Okay, so we'll have a over x minus 1, or you can start with x plus 1, whichever one, plus b over x plus 1. Okay, so now if I multiply through by the LCM, which is x squared minus 1, we'll have 3x is equal to a times x plus 1. That is multiplying this term now by the LCM, which is x squared x plus 1 x minus 1. This x minus 1 will cancel x minus 1, leaving x plus 1. I don't know if it makes sense. Okay, then the same thing happens here. We have x minus 1, right? So if we open up the brackets, we'll have 3x is equal to ax plus a plus bx minus b. Okay, so comparing the coefficients, so the coefficients, okay, I have 3x here, so the coefficient of x here is 3. So let me mark those that have the coefficient of x. Okay, so I have a plus b to be equal to 3. So aside the ones marked, the remaining ones are called constants because they don't have x, right? Unfortunately, on the left hand side, we do not have any constants. That means the constant there is 0. So we equate to 0. So we have a minus b, picking the constant, is equal to 0. So the equation is set, simply set. So we can decide to add. If we add these two equations, that means we are eliminating b to find a. If we now decide to subtract the two equations, that means we are eliminating a to find b. So whichever way is still way. So let's add. So when we add, we'll have 2a to be equal to 3. So if 2a is equal to 3, it means that a is equal to 3 over b. So if a is 3 over b, sorry, 3 over 2. Where did I get 3 over b from? So if a is 3 over 2, I'm thinking of b too much. That's why 3 over b is So now to find b, substitute a into 3 over 2 into any of the equations. So we can have, okay, let's pick the first one, a plus b to be equal to 3. So in place of a, we'll have 3 over 2 plus b is equal to 3. So if we collect like terms there, we will have b to be equal to 3 minus 3 over 2. Okay, so if we remove 3 over 2, I think 3 over 2 plus 3 over 2 will give us 3. That means b is also 3 over 2, right? So we have a and b have the same value. So if that's the case, what do we do? So coming back, we've gotten our a and b, so let's replace 3x over x squared minus 1 is equal to, our a is 3 over 2 into x plus 1 plus our b, which is also 3 over 2 into x minus 1. Now, taking it back to integration, since we have 3 over 2, 3 over 2 as a common term, we can actually decide to factor it out as 3 over 2 into 1 over x plus 1 plus 1 over x minus 1. So now remember we are integrating, so let's sneak in our integral sign with respect to x. So what happens? Okay, so now one of the fundamental knowledge of integration is that if I have 1 over x plus 1, the integral of this is simply ln, that's the natural log of x plus 1, right? Okay, so that means we're going to have 3 over 2 ln x plus 1 plus ln x minus 1. Then we bring in our constants. Okay, so so we have 3 over 2 ln x plus 1 x plus 2 x minus 1 plus c. Okay, as simple as ABC. So I believe that you've gotten a clear understanding of the basis of integration. All right, so one thing I want you not to forget is this, that in integration, first of all, add 1 to the power. You get a new power, then you divide by the new power. When limits are not known, don't forget to add your c. When the limits are known, remember it is upper limit. That's when you are done with integration, substitute the value of the upper limit. Whatever value you get, write it down, substitute the value of the lower limit, whatever you get, subtract it, upper minus lower, and that gives you your value. So I believe you enjoyed the video. Please do well to like, share, subscribe, and join us in our next class for another interesting topic. Bye.